Okay, I'm back. Alrighty, so Taylor and Maclaurin series expansions of common functions is what we're going to work on for this video, which will most definitely be shorter than my previous one. Okay, so you're responsible for memorizing the Maclaurin series for certain functions and their intervals of a convergence. In particular, 1 over 1 minus x, which I think we actually already had talked a little bit about, e to the x, sine of x, cosine x, natural log of 1 plus x, and 1 plus x to the r. Now that last one we haven't talked about yet, and that's going to kind of fall under the binomial series thing. Let's go do some examples, because this is basically about doing, and so more of what we were doing last time. So let's find the Taylor series for f of x centered at a equals 0, the Maclaurin series for natural log of 1 plus x. And we're going to find the interval of convergence and then play games with it, because it's always fun to play with your series, right? Gotta have fun. Okay, so let's do part A. So f of x is the natural log of 1 plus x. So f of 0 is the natural log of 1 is equal to 0. Now, I feel like we've done this one already, but I don't think it hurts to do it multiple times. And so that being said, I'm going to do it multiple times. F prime of x is 1 over 1 plus x. So f prime of 0 is, well, 1. And I'm going to write this as 1 plus x to the negative 1. So second derivative is going to be negative 1 plus x to the negative 2. So f double prime of 0 is going to be negative 1. Third derivative is going to be 2 times 1 plus x to the negative 3. So the third derivative is going to be equal to 2, which we can also write as 2 factorial, because 2 is 2 times 1. The fourth derivative is going to be what? So it's going to be negative 3 times 2 times 1 plus x to the negative 4, which we can think of as negative 3 factorial times 1 plus x to the negative 4. So the fourth derivative at 0 is going to be negative 3 factorial. And by now, with the experience that we've had with other things, you might see that the nth derivative is going to be, well, we have a negative 1, and it's negative when n is positive. So I'm going to write this as an n minus 1 only because we have an n minus 1 factorial going on, and then 1 plus x to the negative n. And so that means when I evaluate that at 0, I'm going to get a negative 1 to the n minus 1 times n minus 1 factorial. Dot, 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 because this keeps going on forever. Okay, so where the series converges, we haven't talked about that or determined it yet, so we're just going to say wherever it converges. I don't know, and I don't care for the moment. We know that f of x is going to equal f of 0 plus f prime of 0 times x minus 0 plus f double prime of 0 over 2 factorial times x minus 0 squared. Right, the nth derivative over n factorial, x minus 0 to the n, and this keeps going forever. It's an infinite series after all, so that's kind of what they do. Okay, so I have 0 plus 1 times x minus, what was that second derivative? 1 over 2 factorial x squared plus, actually, I think I'll put the next one in too. 2 factorial over 3 factorial x cubed minus 3 factorial over 4 factorial x to the 4th. Negative 1 to the n minus 1 factorial over n factorial x to the n. So we have x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th. plus negative 1 to the n minus 1. Sorry, that was an n minus 1. Over n minus 1 times x to the n plus dot dot dot. Which we can write as the summation n going from 1 to infinity, negative 1 to the n minus 1. And when I put n minus 1, I do that every time. That's supposed to be an n over n x to the n. Now, we can do an n minus 1 or an n plus 1. I think if we want to match, for some reason, my notes, I have an n plus 1. It doesn't matter, though. It's all the same. I'm not sure what your book does. I assume n plus 1, so no biggie. We'll just throw a plus in there. We'll just throw a plus in there. Just throw a plus in there, a little plus in there, and a little plus in there. So remember that negative 1 to the n plus 1 and negative 1 to the n minus 1 are the same animal. B, let's find the convergence. So remember, in B, we're doing the interval of convergence. So let's do the ratio test. R is going to be the limit as n goes to infinity of the n plus first term over the nth term. So what is the nth term? It's negative 1 to the n plus 1 over n x to the n. And the n plus first term is going to be negative 1 to the n plus 2 over n plus 1 x to the n plus 1. So I'm looking at the limit as n goes to infinity of the ratio of the absolute values of those. So just plug those in, stick an absolute value around them. So what do we need an absolute value of? Let's think about this. So the absolute value of negative 1 is positive 1. X may be negative. So if x can be negative, we have to put an absolute value there. All right, I feel like this is not going to be too evil, right? Because just going to do our thing. And let's see. So remember that this is the same as absolute value of x to the n times the absolute value of x. And so we can cancel out the x to the n part. So we're going to be looking at the limit as n goes to infinity of absolute value of x times n over n plus 1. We can pull out the absolute value of x. And as I've said a million times, do not use L'Hopital's rule. It does not apply. These guys are not differentiable. But what I can do is I can divide the numerator and denominator by n. So if I do that, I have the absolute value of x times the limit as n goes to infinity of 1 over 1 plus 1 over n. So I get the absolute value of x times 1. For absolute convergence, what do we need? We need absolute value of x less than 1. Well, that's not difficult. So x is between 1 and negative 1. And now we have to check the endpoints to see if we have conditional convergence. Or absolute, as the case may be. So in fact, I actually am just going to say for convergence. Let's go to, okay, so we've got convergence there. All right, so if x equals negative 1, what does our series become? So we have negative 1 to the n plus 1 times negative 1 to the n over n, which is going to be, well, negative 1 to the 2n plus 1 over n. which is just negative 1 over n. So I have negative summation n going from 1 to infinity of 1 over n, and this diverges because it's the harmonic series. What about if x equals 1? So I'm looking at x being replaced by 1. And so, well, 1 to any power is just 1. And we know this converges because it's the alternating harmonic series. And the alternating harmonic series from the previous chapter we talked about, we know it converges. So the interval of convergence is actually -1 less than x less than or equal to 1. I believe there was a part C that said, play with me. Find the Taylor series for x squared natural log of 1 plus x. Right, so I have x squared times, so what's our series? X minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th, yada, yada, yada. So I'm going to get x cubed minus 1/2 x to the 4th plus 1/3 x to the 5th minus 1/4 x to the 6th, yada, yada, yada. And so we could do it that way if we'd like, or you could just do it straight from the series. All right. Or you could just do it straight from the series, right? So what do I mean? So this was our series, and we could just stick it in to the sum. And if we do that, we get x to the n plus 2. Okay, the second one was the natural log of 1 plus 2x. So we take our series for the natural log of 1 plus x and just replace x by 2x. Now, where is this one going to converge? This one's going to converge if -1 is less than 2x is less than or equal to 1. So that's kind of an important thing to note here, that the interval of convergence is going to change a little bit, right? So for this one, x is going to be greater than a half and less than, or greater than -1/2 and less than or equal to a half. And the third one was, what is the natural log of 1 plus x squared? So again, we do the exact same thing. We start with our series and just replace x by x squared. And the nice thing is that we absolutely know the convergence. Well, this converges if hold on, if x squared is greater than -1 and less than or equal to 1, but well, what does that mean? That means well, this is always true, right? X squared is always greater than -1. But the fact that x squared is less than or equal to -1 here means we're still back to the same thing. Well, we're almost back to the same thing, right? Except for here, x is -1 is going to count. Okay, so that was a fun and exciting little example playing with series. Let's do one more, and we're going to find the Mclaren series for sine of x. And so that means that we're looking for the Taylor series, remember, centered at a equals 0. Okay, so f of x is sine of x. So f of 0 is sine of 0, which is 0. F prime of x is cosine of x. So f prime of 0 is cosine of 0, which is 1. F double prime of x is negative sine of x. So f double prime of 0 is, well, 0. And the third derivative is negative cosine of x. So the third derivative at 0 is going to be negative cosine 0, or negative 1. And when you do the fourth derivative, you get right back to the function itself. And this sort of keeps repeating. So if you think about it, okay, so where the series converges, right, we don't have a, well, we do have a general term, but we're going to have to work a little bit to figure it out. So let's not deal with it here. We're going to deal with it when we're actually figuring out what the series looks like. So where the series converges, right, we're going to have f of x is equal to f of 0 plus f prime of 0 times x minus 0 plus f double prime of 0 over 2 factorial x minus 0 squared. Okay, I feel like I need more room, so I'm just going to move this over. Hopefully, I'm going to move this over. Plus the third derivative over 3 factorial x minus 0 cubed, etc. So I have 0 plus x plus 1 over 2 factorial times 0. Well, basically that's 0. Minus 1 over 3 factorial x cubed plus 0 x to the fourth. And then if we did another derivative, we'd get 1 over 5 factorial x to the fifth plus 0 dot dot dot. Okay, so what's going on here is you'll notice that the only place where we have things that are not 0 is when n is odd. Okay, so how do I write n odd? If I want my series to start from 0, to get odds, you get 2n plus 1 for n being 0, 1, 2, right? That gives you, 1, 3, 5, 7. And so we use that, and we get that our series is going to be the summation n going from 0 to infinity. The first term is positive, so we're going to have a negative 1 to the n. We only have odd things, and they're all factorials. So we have 2n plus 1 factorial, x to the 2n plus 1. And so that is what the Taylor series for sine of x is. Now let's find the interval of convergence. I seem to be going into shadow. I'm getting shadowed. So the interval of convergence, right, again, use the ratio test. So the nth term is negative 1 to the n over 2n plus 1 factorial, x to the 2n plus 1. So the n plus first term is going to be negative 1 to the n plus 1 over 2 times n plus 1 factorial, x to the 2 times n plus 1 plus 1. So that gives me negative 1 to the n plus 1 over 2n plus 3 factorial x to the 2n plus 3. Let me just get the absolute values out of my hair. Yes, out of my hair. So the factorial is always positive. I probably should sort of scoot this over here. So absolute value of the negative 1 gives me a 1. I get an absolute value of x to the 2n plus 1 over 2n plus 1 factorial. And for the n plus first term, when I take the absolute value of that guy, you can kind of see what happens. I'm going to get the absolute value of x to the 2n plus 3 divided by 2n plus 3 factorial. So r is the limit as n goes to infinity of the n plus first term in absolute value divided by the nth term, which is the limit as n goes to infinity of absolute value of x to the 2n plus 3 over 2n plus 3 factorial, all divided by absolute value of x to the 2n plus 1 over 2n plus 1 factorial. So I get the limit as n goes to infinity of absolute value of x to the 2n plus 3 over 2n plus 3 factorial times the reciprocal of the thing I'm dividing by. So we get the 2n plus 1 factorial, absolute value of x to the 2n plus 1. So let's simplify this. So the thing we want to remember is 2n plus 3 factorial is 2n plus 3 times 2n plus 2, all times 2n plus 1 factorial. Well, that was entertaining. Oops, that's not what I want. Okay, we now interrupt our program for some technical difficulties. Okay. So stuff's going to cancel now, as we'd like. This is going to cancel with this. Notice also that I'm going to be left with the limit as n goes to infinity of the absolute value of x squared divided by 2n plus 3 times 2n plus 2. Now, even if you want to take the absolute value of x squared, right, you could probably see that this limit is the big 0. So that tells me that the series converges for all x. So what's the interval of convergence? If you said minus infinity to infinity, you are absolutely right. Awesome. So now for your edification, you have an exercise, and I'm going to call this a video, and I'm going to let you work on the exercise and be in suspense until the next recorded lecture. Have a great day. Stay safe.